everyone. In this video, we are continuing with paper 3, that is Advanced Practical Skills of AS Level Chemistry. We are doing part 3 of the series wherein we are solving of paper 3 from Feb March 2021. So we have solved the first and the second question in the first and second part respectively. If you haven't watched those, you can go ahead and watch those video and then come back to this video. I'll be putting the link in the description. Now, in today's class, we'll be solving question number 3, which is qualitative analysis, wherein we'll be doing salt analysis. So this is the question. Before starting with the question, they have given some guidelines for the students in order to proceed with the qualitative analysis. So let's understand what is the requirement from their point of view. So the first thing is that where reagents are selected for use in a test, the name or the correct formula of the element or the compound must be given. So whenever we are selecting any reagents for testing something, we have to give the proper name, and or we can even give the formula, but the formula should be correct. Okay, this is the first expectation. And then at each stage of the test, you are to record the details of the following. So what and all must be recorded? The first thing is the color change. See, okay, if there is any color change, you will have to write that in your observation. And the next one is the formation of precipitate and its solubility in excess reagent. So first whenever we are adding two reagents, we'll see whether it is forming a precipitate. Precipitate means a solid in a solution. Okay, and if we are adding excess of the reagent, if the solid gets dissolved, then we say that the solid is soluble in excess, or else we say that it is insoluble in excess. So we have to perform that test as well. And the last is to test the formation of any gas and its identification by a suitable test. So if at all there is any gas test, then you have to do the gas test by identifying a suitable gas test. So they won't be giving you directly which gas test to perform. You have to identify it and do the process. And next, you should clearly indicate at what stage in a test a change occurs. So that is, if they are asking you to heat something, so before that, if they are asking you to add two reagents and then heat, so you have to mention what happens when you add two reagent. Okay, if there is any observation, you will have to write that. And then after heating, what is the observation? That should also be added. So at every stage, you will have to write the observation. So first after adding the substance, and then the next result will be after heating. So in this particular case that we just mentioned. Next is, if any solution is warmed, a boiling tube must be used. We can't use a test tube. Test tube is easily breakable, so we have to use a boiling tube. Boiling tube has even more thicker uh, walls, therefore it won't break easily. Rinse and reuse the test tube and boiling tubes where possible. So even if you are not provided with n number of boiling tubes and test tubes, it is your duty to rinse and reuse the boiling tubes and test tubes. Okay. Now, no additional tests for ions present should be attempted. So these are the expectations from Cambridge for your qualitative analysis. Let's dive into the question. So this is the question 3. It says Fa6 contains one cation and one anion, both of which are listed in the qualitative analysis notes. Okay. The first question is, heat Fa6 gently for 1 minute in a hard glass test tube. What do you mean by hard glass test tube? It's nothing but a boiling tube in which it is supplied. Then heat it strongly for no further change occurs. Record all your observations. So what and all observations should you record? You have to check whether there is any color change. You have to check whether any precipitate is formed and solubility in excess reagent test, which we don't have to do it right now because we are not adding any reagent, we are just heating it, right? And then you have to test for gases also. So how will you understand which gas test and all to be performed? So before understanding that, we'll just look at the question. It says there is only one cation and one anion, and both are given in the qualitative analysis sheet. So if we look at the qualitative analysis sheet, these are the possible cations, which are aluminum, ammonium, barium, calcium, chromium, copper, iron, iron 2 and iron 3, magnesium, manganese, and zinc. Okay, so these are the possible cations, and the anions possible are these. which are carbonate, chloride, bromide, iodide, nitrate, nitrite, sulfate, and sulfide. Okay. Next is the gas test. So these are the possible cations and anions which can be seen in your salt. Okay. Uh, since it is mentioned that we have to do the formation of gas and identification by a suitable gas test, we might have to do a gas test over here because it has heating over here. So let's understand which gas test to be performed. So for that, if you look at the test for gases, there are 5 gases which are ammonia, carbon dioxide, chlorine, hydrogen, and oxygen. Now, if if oxygen is present, then obviously some reagent like hydrogen peroxide will be added in order to produce oxygen. Okay, so if you are adding a reagent, especially when hydrogen peroxide is added and then you are heating it, then the gas will be oxygen for sure. Okay, and you will have to do the test for uh, oxygen. That is, you have to check whether the splint reglows or relights. Okay, so oxygen test can be performed when hydrogen peroxide is present as a reagent and heating is also present. Next is hydrogen. For hydrogen, you have to add a metal and then heat it, or just metal as such without heating also might work in some case. Okay, so but what is required, a metal should be added to the given salt, and then oh, there is a possibility that hydrogen could be produced as a product. Okay, if a metal is added like aluminum, magnesium ribbon and all, then hydrogen will be formed. Okay, so if that is the case, then you have to test for the hydrogen gas, wherein you will be using a splint test, and if you hear a pop sound, it is going to be hydrogen. Note, you will be doing hydrogen gas test if a metal is being added to the given salt, and it can be with heating or without heating. Okay, so this is when you will test hydrogen when a metal is being added to the salt. Now, if it is carbon dioxide, usually an acid will be added. An acid will be added to the given salt, and then you might have to test the presence of carbon dioxide by passing the gas produced through lime water. Okay, so understand that if acid is being added to a salt containing carbon dioxide, then obviously very vigorous effervescence will be produced. Okay, like how you see in aerated drinks, whenever we shake the aerated drinks, effervescence will be seen, right? Similarly, if you add an acid to a salt containing any anion that can produce carbon dioxide, then obviously effervescence will be seen. Okay, now this can also be done with heating or without heating. Okay, now the next one is for chlorine. For chlorine, we just have to heat it, and then we have to show it. We have to test the gas by using a damp litmus paper. And for ammonia also, we have to just heat it, or we can do it by adding NaOH and aluminum foil. If these two reagents are added and heated, then also we will get ammonia, or else just by simply heating also we will get ammonia. Okay, so for chlorine and uh, ammonia, we will be using litmus paper test. So since over here in our question they have just asked us to heat, and since they haven't added any reagents, we will go ahead with the testing of ammonia or chlorine. Okay, because in those we can do the test without adding any reagents as well, right? So we will be testing it for testing the gas for ammonia or chlorine. So in both case, you can do the test with red litmus. So whenever we are using litmus, it should be damp in nature. So I'm going to do the damp red litmus test for this case when heating. So when I did the test, the damp red litmus turns blue in my case, which means it it can be ammonia, because chlorine just bleaches it, meaning it will decolorize the litmus paper. But that didn't happen over here when I did the test. Rather, the litmus turned blue. Okay, and then after heating for some more time, I was able to see white fumes or vapors being produced. So there, 2 marks, 2 points. The first point is damp red litmus turns blue, and the next one is white fumes or vapors formed. These are the observations that I got. So why did we do the litmus paper test? Because we weren't adding any reagents. If we added acid also, if we just added acid also, there was no fizzing as such seen, and the substance had a pungent smell also. So obviously we can go ahead with the litmus paper test, because the other options can be neglected as there is no addition of any other reagents like hydrogen peroxide, metal, or acid. So the next is identify the ion that must be present in Fa6. So if we try to look at the qualitative analysis sheet, we have ammonium, which is NH4. That doesn't give any precipitate when NaOH is added, but ammonia is produced on heating. Just by heating the substance, we get ammonia, right? Same like that, we got ammonia just by heating the salt. So we can say that the given substance contain ammonium ion. We are not going to confirm nitrate or nitrate because we didn't add aluminum foil and all, right? If it was if we added aluminum foil and then if we heated, there could be a possibility of nitrate or nitrite ions and NaOH. If we added these reagents and then if the litmus paper turned blue, then there could be a possibility of these two ions. But that was not the case. We just heated it and we were able to see the color change. Therefore, ammonia was produced by heating alone. So we can say that the ion that is present is ammonium ion. We are moving on to the next question, which says Fa7 and Fa8 are aqueous solution. Each of the solution contains one cation and one anion, both of which are listed in the qualitative analysis notes. Use 1 centimeter depth of Fa7 or Fa8 in the test tube for the following test. Complete the table by recording your observations. So whenever you are taking the solutions in a test tube, it should only be up to 1 centimeter from the bottom of the test tube till 1 centimeter height. You will be taking the solutions for doing the test which are mentioned in the table. Okay, so again here also it is just one cation and one anion, and both of these are given in the qualitative analysis sheet. Okay, so let's try and do this test. So the first thing is add a few drops of aqueous acidified potassium manganate. So potassium manganate can act as an oxidizing agent. Now, if it turns yellow, then the substance could have a basic property or it could be an alkali. Okay, so in my test, what happened was the purple color didn't disappear, rather it formed a yellow solution. A yellow solution was formed. So this could mean that it could be a alkali. That is Fa7 could be an alkali. Okay. So you have to write that it is a solution because there was no precipitate formed. It was just the solution that turned yellow. No PPT. Okay, so I'll just talk about the solution because there wasn't any PPT formed and the color of the solution became yellow. Okay, then add a few drops of starch indicator. When the starch indicator was added, again, what happened is that the solution turned blue-black. Again, no PPT as such, just the solution turned blue-black. Okay, so this was my observation. Then we are doing the test, second test. So this particular test which we did is not there in the qualitative analysis sheet. It is just for us to understand that it is getting oxidized. Okay, so this is a test that you have already studied in your theory, wherein a substance gets oxidized in the presence of an oxidizing agent. Okay, so now let's so you do this is just to test your understanding of how to perform the test, but for identification and all you will be requiring this test because this is the one which is there in your qualitative analysis sheet. So let's understand what is the test. Add a few drops of aqueous silver nitrate, then add aqueous ammonia. So let's so since this is not a common reagent, what do you mean by common reagent? It is NaOH. Common reagents are NaOH and NH3. So NaOH or NH3 are the common reagents which are used for testing the cations. So since it is not belonging to the common reagents, that is silver nitrate doesn't belong to the common reagent NaOH and NH3, we can very well say that this is not a test for cations, because only in cations we will be doing common reagent test, which is with aqueous NaOH and aqueous NH3. So since we are not using both of these reagents, we are not testing for cations in this particular test. Rather, we are testing for anions. So let's look at the test for anions. So in the test for anions, each of the tests is different. So if we look at our reagent, it has silver nitrate. So anything that has silver in the test, like chloride has Ag plus, which is silver, bromide has Ag plus, which is again silver, iodide also has Ag plus. So in we are trying to see whether these substances are present in our compound. Okay, if it gives white precipitate, it is going to be chloride. If it gives cream precipitate, it is going to be bromide. And if it is yellow, it is going to be iodide. So how will you understand whether the color? So if it is white, it will be pure white as the paper. Okay. And if it is slightly dirty in color, that is a dirty white or off white, can be called as cream. Okay, it won't be like the color that you see, the cream color, which you might think it would be. Rather, it would be just a off-white color, which can be called as a cream color. And then yellow PPT will be very slight yellow. Okay, if it is not pure white, or if it isn't dirty white, you can go ahead with yellow. Okay, it will have a very small tinge of yellow. And then we will be testing it with NH3 and check the solubility of the precipitate to confirm the ion present. Okay, that is NH3 is used as a confirmatory test to reconfirm the presence of a given anion. Okay, so we are testing for chlorides, bromides, and iodides, and the possible results that could come are white, green, yellow. So you have to keep in mind the possible results and then do the test. So when I did the test for Fa7 and Fa8, I got two different colored precipitates. For Fa7, the color was yellow. So yellow means it's not very dark yellow. You can say it as very pale yellow. You can say it as pale yellow, or you can just write yellow itself. So pale yellow precipitate was obtained. That is important. Okay, or just write yellow precipitate form. Okay, then in the next one, that is in case of Fa8, I got pure white. That is white means the color of the white colored paper. So white precipitate was formed when I added silver nitrate to Fa8. Now, to do the confirmatory test, that is by adding ammonia, if I was able to see that the precipitate is insoluble. Okay, PPT is insoluble in ammonia. And when I did the same test for Fa8, I was able to see that the precipitate is soluble in ammonia. Okay, so these were the results that was obtained for me during the test. So from this, we can say that the anion for Fa7 is iodide, because yellow precipitate was formed and it was insoluble in NH3, which means it is iodide for Fa7. And for Fa8, I got white precipitate, which is soluble in ammonia, which confirms the presence of chloride ions. Next, let us go to test 3, wherein we are adding sodium hydroxide. Sodium hydroxide belongs to common reagent, so which means we are doing the test for cations. So the possible results are white precipitate or faint white precipitate, again white precipitate, or gray-green precipitate could be obtained, or pale blue precipitate can be obtained, or green precipitate, or red-brown precipitate, or white or off-white precipitates could be present. Okay, so these are the possible results, like white, gray-green, and then red-brown, green, or off-white. Or else you won't even get any precipitate. That is also a possibility. Or you can get very few amount of precipitate. Okay. So these are the possible results that could be obtained. So when I did the test using uh, NaOH, when I added NaOH to Fa7, I got, so this is Fa7, when I added NaOH to Fa7, I didn't get any precipitate. That is, no PPT was formed, which means no PPT formed, which means it could be ammonia, because ammonia is the only cation that doesn't give any precipitate when NaOH is added. So there could be a possibility of ammonia. Now, next one, when I added the same reagent for Fa8, that is when I added sodium hydroxide, aqueous sodium hydroxide, to the Fa8 solution, I was able to get white PPT initially. And whenever we get a PPT, we have to do excess reagent test as well. So when I added double the quantity of NaOH, so initially I added 1 or 2 drops to see what is the uh, precipitate that will be obtained. And after that, I have to add excess reagent. Excess reagent means whatever is the quantity that is present in the test tube, double of that will be added. So double that of NaOH was added, and I was able to see that the precipitate didn't dissolve, which means it is insoluble in excess. So this was the result that I got. So white precipitate, insoluble in excess. Now let's move on to the next test, wherein we have to pour the mixture into a boiling tube and warm gently and carefully. So initially we got no precipitate, right? So when no precipitate is formed, if we look at the qualitative analysis sheet, it could be ammonium. So in ammonium, when there is no precipitate formed, as a confirmatory test, we are doing the test for ammonia. That is, ammonia will be produced on heating. So that is what we are trying to do. So what is the test for ammonia? Um, the gas test for ammonia says that the damp red litmus paper turns blue. So that is the test which we are going to perform here right now. So I'll be using a damp red litmus paper and I'll be testing both the solutions. Okay, so I'll be heating Fa7 and I'll be doing the damp red litmus paper test in Fa7 as well as in Fa8. So over here, what happens is that damp red litmus turns blue. While here, there wasn't any change. The litmus paper didn't change as such, or we can say that no change observed. Okay, no change. Because I was not able to observe that the color turns blue. So I'll write no change observed. Now we are adding a piece of aluminum. So remember, aluminum foil is a metal, right? So over here, we are adding a metal. So whenever we are adding a metal, you will have to test for hydrogen gas, because a metal when added to a solution produces hydrogen. So here we have to test for hydrogen gas, right? So we are going to uh, write the observation by doing the test for hydrogen. So what is the test for hydrogen? Splint test. We will light a splint and bring it near to the mouth of the test tube, and if it pops, if it extinguishes, that is the fire extinguishes with a pop sound, then it means that there is hydrogen gas present. So when I tried out that test in this solution, that is Fa7, there was no change observed. There wasn't any observation as such. But for this compound, I was able to see that there is a change, pop sound. So I'll write as it is there in the qualitative sheet. It says pops with a lighted splint. Okay, so I'll write pops with lighted splint. Okay, so these were the observations. Now the next is to add few drops of dilute sulfuric acid. When I did this, I was able to see that there was no precipitate for Fa7, but for Fa8, I was able to get a white PPT. Okay, So these are the results that I got. Now from these results, I have to infer the chemical formula of Fa7 and Fa8. So it has both cation and anion. So let's start with Fa7. So from this particular test, that is test 2, wherein we did the test for anions, we were able to see yellow precipitate, and the precipitate was insoluble in ammonia, right? So if we look at the test for anions, there are three tests that we did: chloride, bromide, iodide, and we were able to see yellow precipitate insoluble in aqueous NH3, which shows the presence of iodide ion. So obviously the anion is going to be iodide. And what will be the cation? From the test with NaOH, we were able to confirm that the anion which was present in Fa7 was ammonium. So Fa7 contains ammonia as its cation and iodine as its anion. So the formula will be NH4I. Now, if you try to find out Fa8, we have already seen from test 2 that it produces white precipitate, and the precipitate is soluble in ammonia, which means the compound is chloride. Now we have to find the cation. So for finding the cation, we will be using the observations from test 3. So in test 3, we got white precipitate, which is insoluble in excess, and there was no change when we heated the solution. All right. So if we try to look at the qualitative analysis sheets, we can see that barium gives a faint white precipitate. That is also only possible when the reagents are not pure. If it is pure, it gives a proper white precipitate, right? And then you can also get a white precipitate in calcium. Okay, they have not mentioned about what is the excess reagent test that is going to happen. And then we are getting for magnesium white precipitate insoluble in excess. So it could be magnesium chloride, calcium chloride, or barium chloride, because we don't know what happens to the excess of these. Okay, so in that case, if we try doing the next test, if we try looking at the next test, which is with sulfuric acid, when we are adding sulfuric acid, it forms a displacement reaction. Okay, and since we are getting a white precipitate, the given salt, that is the given sulfate salt, in displacement reaction, obviously the sulfate ion will get displaced and join with the metal to form the salt. So it can form salts. It can form salt with calcium, can form salt with barium, and it can form salt with magnesium. Okay, if it tries to form salt with calcium, it is going to be partially soluble because calcium sulfate are partially soluble. Soluble PPT will be obtained because calcium uh, salts are partially soluble. While if we take the case of barium, when barium sulfate is produced, sulfates of barium are insoluble. And for magnesium, we will be getting magnesium sulfate, which is soluble. So which means we can neglect magnesium, because we won't be getting a white precipitate when we add sulfuric acid, because the displacement reaction will form magnesium sulfate, which is soluble in uh, in the compound that is produced, while barium and calcium are something which is insoluble. Since calcium is partially soluble, we can go ahead with barium. So the compound Fa8 will be BaCl. If you try looking at the reaction, ionic equation for the reaction, it will be like Ba2 plus, because the salt contains barium ions, right? So Ba2 plus aqueous plus SO4 2 minus, because the anion is SO4 2 minus. Again, that will be in aqueous, gives BaSO4. Okay. This will, this is a solid. This will be the ionic equation. I hope this is clear. Uh, with that, we are winding up salt analysis question as well. I hope it is clear. Thank you.